This video covers section 2.7 Rational Expressions. A rational expression actually is a fraction that top and bottom of that fraction are polynomials. You see here a definition that an algebraic expression where both numerator and denominator are polynomials, and we call that algebraic expression a rational expression. We can simplify a rational expression. Look at these examples. We have x over x squared minus 2x. To simplify a rational expression, we need to use our knowledge from factoring. Means, for this example, we have x on the top, we factor denominator. So if I factor x from x squared and 2x is x times x minus 2. Now we can eliminate x and x. So the final answer is 1 over x minus 2. This 1 over x minus 2 is simplified form of x over x squared minus 2x. So to simplify a rational expression, we first use factoring, then eliminate those factors that are the same in top and bottom of the fraction. To multiply rational expressions, we multiply tops by each other, bottoms by each other, and then we simplify the answer. Please note that because we are working with fractions, always denominator must be non-zero. In any form of fraction, denominator cannot be 0. And to divide two rational expression, a over b divided by c over d, always we keep the first fraction, change division sign to multiplication, and flip over the second fraction. Now instead of division, we have multiplication. Multiply tops by each other, denominators by each other. Let's solve a few examples. Let's do multiplication between these two rational expressions. We mentioned when we multiply two fractions, we have a new fraction that the top of this fraction is multiplication of tops of two fractions, 3x times 4, 12x, and denominators multiplied by each other means 5x times x plus 3. Remember, always you must simplify your answer. In this form, on the top we have 12x, denominator 5 times x plus 3. Here x is one of the factors that we can simplify or cancel. So the final answer is 12 over 5 times x plus 3. Here we have division. A rational expression divided by another rational expression. So the first step, it could be keep the first fraction, change division to multiplication, and flip over the second fraction. Now we multiply these two fractions. So denominator is 5x times x squared minus 4. And top of this fraction is x cubed times 3x minus 6. We need to check if we can factor. You see this parenthesis and this parenthesis we can factor. So is going to be equals x cubed. I can factor 3 from this parenthesis. So it's going to be 3 times, I'm going to write it on the top, 3 times x minus 2. So because 3 is a number, it's okay, I write it before x cubed times x minus 2. In denominator, 5x. Now x squared minus 4, we can write it as x minus 2 times x plus 2. So it's 5x times x minus 2 times x plus 2. The last step is simplifying. I can cancel x minus 1, x minus 2. There are factors on the top and denominator. This x with one of these x's. So I have x2 here. The final answer would be 3x squared over 5 times x plus 2. You see, we cannot write it simpler than this one. We can add or subtract rational expressions. They are fractions. If they have the same denominator, addition and subtraction is so easy. So addition between these two fractions with the same denominator is going to be a new fraction with the same denominator. Just add top of these two fractions. 3x plus 5 minus 5 plus x minus 4. Now it's going to be a new fraction. Like terms, 3x and x is going to be 4x minus 5 and minus 4, negative 9 over x. So if denominators are the same, addition or subtraction between rational expressions is easy. Now look at this example. We have subtraction between these two rational expressions, but denominators are not the same. If denominators are not the same, we need to use least common denominator. First, if I can factor denominators, I need to do that here. X squared minus 9, you can write it as x minus 3 times x plus 3. So if I rewrite this fraction, this is x over x minus 3 times x plus 3 minus the second fraction 2 over x plus 3. If you compare the denominator of these two fractions, you see both have factor x plus 3, but the first fraction has x minus 3 extra. We can add two fractions if they have exactly the same denominator. So I need to multiply the denominator of the second fraction by x minus 3. Because this is a fraction, if I multiply any non-zero term by denominator, I have to multiply it by top of the fraction as well. So if I rewrite both fractions, now I have x over x minus 3 times x plus 3 minus 2 times x minus 3 over x minus 3 times x plus 3. Multiplication is commutative. I can switch these two. Now we have the same denominator. So answer is a new fraction with the same denominator. This is subtraction. So x minus 2 times x minus 3. Now I'm going to simplify top of the fraction. So denominator the same, x minus 3 times x plus 3. And top of fraction is x minus 2x, negative times negative is positive, plus 6. x and negative 2x are similar term. X minus 2x is negative x plus 6 over x minus 3 times x plus 3. This is the final answer for this question.